Good morning, students. This is the day 2 lessons on functions, Algebra 1 style. There are some concepts, again, that I've talked about in Math 6, and it's just now you're just extending on some of those topics. So every day we make decisions based on effects of our actions. Our independent actions may many times have reactions that are dependent on our choices. In most situations, there exists an independent variable, the value that we can change, and a dependent variable, the value that is determined by the independent variable. We've discussed this. For example, we know that there is a relationship between the number of hours that Sarah works at SeaWorld in July and the amount of money she will earn on her paycheck. What depends on what? Does the hours working depend on the money made, or does the money depend on the hours worked? In this situation, the independent value, the variable that Sarah can directly change, is the number of hours she works. The money she earns for working that many hours depends on the dependent variable. So in the following situations, determine the independent and dependent variables for the following variables, okay? So let's go about this and do this. It's the number of dishes that need to be cleaned and the number of people at the party. So which one of these two situations you have the number of dishes that need to be cleaned and the number of people at the party? Which is the independent variable? Which is the one that you can control? I would think that the number of people at the party would be your independent variable, just because the number of dishes you need to wash is going to be dependent on the number of people at the party. The age of a BMW and the value of the car for the first 10 years. Okay, the age of the BMW and the value of the car. And I'm going to say age of BMW, and the value of the car is going to be dependent on the age. Value of car. Yeah. At least I would think it this way. I can see you kind of taking it the other way, but this is the way I see it. I guess you can say if you determine the value of the car, it's going to be big. No, this is the way I see it. I don't know. You can maybe make it. This is one that's slightly in the gray area for me if you truly make a possible case, but I think this is the way I see it. The amount of Fredericksburg peaches grown and the price of peaches. Well, market, I mean, look at right now, the market. Toilet paper probably is being upcharged right now because of the high demand for it. So if you have less of something, then, yeah. If you have more peaches grown, they're going to cost a little bit less. Okay? That's what I would think. Amount of peaches grown and price. The amount of food in a well-stocked refrigerator and the number of people who can eat an afternoon snack. Well, number of people who can eat. I mean, I'm thinking through this. The amount of food in a well-stocked refrigerator and the number of people who can eat an afternoon snack. Number of people who can eat and amount of food. I'm only saying this because of the well-stocked refrigerator part of it. If it's a well-stocked refrigerator, then it's always going to have food in it, and if people are eating afternoon snacks, you're going to have less food in the well-stocked refrigerator. That's the way I see it. The height of a tree and the number of years since it was planted. This is probably one of the most easiest ones that we've had. Number of years. Number of years the tree has been planted. And dependent is height of tree. The height of tree is depending on the number of years that has been planted. All right, so one way to represent a set of related data is to graph the data using a scatter plot. In a scatter plot, each pair of corresponding values in the data set is represented by a point on a graph. To make predictions using a scatter plot, look for a correlation or pattern in the data. So a positive correlation that when you're looking at a graph left to right, like the way you read, is the graph moving in a positive trend, an upward trend. Think about the way you want your bank account to look like. Okay, that's the way it's talking about. This is going in the positive direction this way and a positive direction this way, left to right. Negative correlation means that when you're looking at it left to right, this is the y values are going down. Okay, that's negative correlation. It's going downwards. And no correlation is that there is nothing that exists. There is absolutely no correlation in the data, and that happens all the time. Undefined correlation. When it's a horizontal line or a vertical line, it's undefined. It's not telling you any information. You don't know if it actually means anything. That's where the whole purpose of a graph is to find meaning of a data set. And in this case, this is just going left to right. It's not going up or it's not going down. It's not giving you any information. And the same thing over here. Example, Joe is a fisherman. He weighs each fish he catches and measures its length. He graphed his data in a scatter plot. So this is his graph right here. As the length of the fish increases, because this is increasing length, their weight generally increases. This is a positive correlation. Statisticians try to draw a line of best fit, a line having approximately the same number of points above and below. Draw a line of best fit. Again, you're going to be doing this way more in algebra classes. I'm just giving you a taste of this, but a line of best fit would look something like that. Okay? If you're going anything, data science is a huge profession right now, and statistics is pretty much a massive part of data science. It's a great profession. I have some family members in it. You're going to be looking at a lot of graphs like this. So this is the start. Day 2, introductory functions. Let me know if you have any questions. Bye.